are many examples of Poka Yoke and mistake proofing that help us avoid defects. Poka Yoke is found in manufacturing, service, and information systems. They can also be found in everyday life. In this module, we will look at some examples of Poka Yoke that you may not have noticed before. Keep in mind that any form of error proofing should be inexpensive, if not free, and as simple as possible. Also, recall that there are different types of inspection. We have judgment inspection, informative inspection, and source inspection. In most cases, and if possible, you want to shoot for source inspection. But if source inspection is not a possibility, or you cannot think of a way to move your Poka Yoke to the source, then begin with informative inspection methods. We will look at examples of Poka Yoke for source inspections. Remember that any form of Poka Yoke is going to be specific to your process, so involve people from the front lines, or the Gemba as we say in Lean, and allow them to come up with innovative solutions. These examples may help spark ideas or generate thoughts, but may not work in your situation. As a reminder, Poka Yokes that occur at the source is a device or method that prevents an error during the process. There are two ways for this to occur: control or warning. Let's look at an everyday example. You may not realize it, but a microwave is a great example of a Poka Yoke at the source. The microwave will not turn on unless the door is completely closed and the start button is pushed. It could be very dangerous if a start button was pushed and the door was still open. This type of Poka Yoke is known as a control Poka Yoke, located at the source. Another example of a Poka Yoke at the source is spell check. Spell check works by linking to a dictionary of words, definitions, and their proper usage. When you spell a word incorrectly, for example in Google Docs, the word is highlighted. This is a warning Poka Yoke at the source. The user can then go back and choose to correct the word or not. You can also set your spell check to automatically change if you want it to. This prevents the document from being turned in with a misspelling and transforming your error into a defect. With these examples in mind, let's look at one example of our three different methods: the contact method, fixed value method, and the motion step method, which are all used as Poka Yokes. We will see you in the next lecture. Let's imagine for a second that you stamp parts on a die. There are only two directions the die could go in the die, but it is not uncommon for a piece to be put in wrong. You recognize this struggle, and in an effort to prevent the pieces from being stamped incorrectly, you build a Poka Yoke into your die. The die can now only fit the part in one direction, because if you try to place it in another direction, it will not make contact the correct way and cannot be put in the die. Another very common example shared in Dr. Shingo's book, Zero Quality Control, Source Inspection and the Poka Yoke Method, is an example of milled and unmilled parts. In the example, parts from an injection molding machine are to be milled before they are processed. But the parts are sometimes not milled. An idea is created to place two small blocks in a chute. The blocks allow a milled part to pass through, but will not allow an unmilled part to pass. This contact method is a great concept that can be applied in many different ways. The fixed value method can be used to control or warn an operator if something does not occur or something occurs too often. To put it simply, the fixed value can count the number of items, steps, or other numerically assigned elements and confirm or identify an abnormality. Let's look at an example of the fixed value method. In the assembly of a part with nuts and bolts, the exact number of nuts and bolts for the assembly is available to the worker. If any of the nuts or bolts are left over after the worker has assembled the part, a mistake is detected right away and the worker can see numerically that he did not use the required number of nuts or bolts. Some other methods that can be used to detect errors with the fixed value method are with dispensers. A dispenser can feed the prescribed amount of an item into a bin. This is used quite often in the medical field. For example, when a pharmacy fills a prescription, a counter is oftentimes used to ensure that the right amount of the prescription is filled. Dispensers or counters can be used in both a control manner and a warning manner. Counters can be used to confirm the number of parts passed by, the number of process steps that have been completed, and they can help determine whether specifications have been met or not. For example, if a torque gun that automatically stops once a preset level of torque has been reached does not reach the required torque, you know there's an abnormality. There are many other ways that the fixed value method can be used. You may want to ponder the following question. Is there any process that I am part of where the fixed value method could be used? When you think of an answer, write it down and go and implement your improvement. To put it simply, the motion step method or sequence method determines whether or not only the appropriate steps of a process are completed. An example of this may be a form that is filled out on the internet. If the form is being filled out in the correct order, each step will allow you to pass to the next step. However, if it is not, it will prompt the user before you can move on and submit the information. Another very effective example that Dr. Shingo shares in his book, Zero Quality Control, Source Inspection, and the Poka Yoke Method, is the example of a device that feeds washers into the machine. The workers struggled with installation of washers and oftentimes omitted or doubled up on washers, which caused problems. In the book, Shingo describes a device that feeds washers onto a platform where they can be picked up and installed. If another washer is triggered before a washer is installed, it forces the washer onto a catch tray so that the operator can only install one washer. As you ponder these examples, consider this question. Is there a process that has a lot of errors or issues similar to the ones described in this example? Can I use a motion step method to warn me of an error or possibly to control a process? As you consider these questions, be sure to write your thoughts down when they come to your mind. You never know. Maybe you will find a process that you can error-proof using the Poka Yoke, motion step, or sequence method. Remember, these examples are meant to prompt innovative thinking, to get you to reflect on what you are doing and what could be done. The basis of all these examples is to prevent errors. With that being said, if your method is not exactly what you saw in this lecture, but it prevents an error, fantastic. That is what it's supposed to do. Thanks for watching, everyone, and we look forward to seeing you in the next lecture.